Good afternoon, students. I'm Ms. Simon Mwalwa, and I will be assisting you with your Mathematics 2 contact class for the 2019 examinations. That means it's examinations for April, August, and November. We are going to look at just few tips on answering exam questions. Few examples of the understanding you will need in order to succeed in your exams, and then we look at the contact details. You should read the questions carefully for you to be able to answer it. Especially for mathematics, there are keywords that you look at in that question so that you can be able to extract the right calculations that you need. Then you should be able to manage your time carefully. Look at the time, look at the marks, and then you should know how many minutes can you spend on a specific question. And then you should answer all the questions, because sometimes you are supposed to do all the calculations, and then the calculations will give you the answer. If you just do not do anything at all, you will not get the mark for your methods. You will not get your mark for the answer. At least if the answer is wrong, at least you'll be able to get based on the way you did your calculations. So do not just leave it blank. So ensure that you are guided by the marks allocated. Your answer should be based on the marks allocated. If they just say, what is the sum? Or what is 2 plus 2? Then you should just answer already directly 4. But if they say, show all your work, then you know you are supposed to show all the steps of the calculations. And then you should put more emphasis on the formulas and the specific concepts. So you should, even if I have to say it, I'm going to say you should memorize those formulas. There's no way you will answer a question that is asking you for a formula if you do not know that formula by head. And lastly, when you come to the exams, don't forget your calculator. Don't forget your ruler, your eraser, your pencil, and the pen. So you don't want to be borrowing things in the exams. Just get prepared. You will use those ones, because in math we do calculations. In math we draw graphs or worksheets and all that. You will need to use all those materials. So let's start with the content. So we are just going to look at a few concepts or a few examples in math in general of the type of understanding that you would need, because if you master that one, then even if you find one similar or just along that line in the exam, you should be able to apply what you have learned to answer the question. So for example, when it comes to graphs, in graphs you either are asked to draw a graph, or you are given a graph, and then based on that you are supposed to interpret it or to answer the questions that are asked after that. So the first one, we have the graph, and they say it is the injuries of the drivers that were involved in an accident on a busy junction. So you have now the males and the females separated. That's why you have, when you look at the bus, they are of different colors. So on there, when you already have the number of accidents, and then you have the drivers. So you should know which one is a dependent variable here and which one is the independent variable. So you have the drivers as the independent variable, and then the number of accidents. That depends now on the number of, on the drivers that were involved in the accident. But mostly you should be able to answer the questions that were asked after that. So like, how many females? We have males and females. This time, you know, we have males and female, but this time they only want to know about females. That's why I say you should be able to pick what is it they want in that question. They only want females, not males. So how many females in total were involved in an accident? So you have the accidents vary. We have the fatal ones that were so like critical. Then we have the serious ones and the minor ones that were not so injured. And then we have those ones that were not involved at all. So now they want the total that were involved in an accident. That means we only have 3: the fatal, the serious, and the minor. So what you do is you have the number of accidents, and then you have the drivers that were involved. And they want to know now how many females. You have females there, and so you say the females that were involved in the fatal are how many. You look at your graph where it meets the number of accidents. Then you say 5. See? How many females in total involved in an accident? And then, no, I'm actually looking at the graph for the fainting color is for males. Sorry, that's why I'm saying we should be careful when we are read the question carefully before we answer. So I was actually already starting to make a mistake. So the bold ones are the one for the female, and the lighter ones are the one for the male. So you look at the female. How many females? You look there. A number of accidents. There are 10. And then the serious, the ones that were seriously injured, you look at the seriously injured one and you can see 25 there. And then the minor injuries where you can see it goes to 30. And then the next one says none. That means that those ones were not involved in a car accident. You don't use them. You don't put them. So you need to know this total. Then you know how many females. And then the next one, how many people in total were not involved in an accident? So again, in that question, they are saying people. They didn't say male, they didn't say female, they just said all the people, everybody that was not involved in an accident. Not involved in an accident is also a keyword. So you calculate whether it's a male or female as long as it's a person. So you have the first one for female, they are 10. And then males are 30. Then you get your answer. Then for those that were not involved. And then the third question, what fractions of the total number of women was involved in serious accident? Give your answer in simplest form. They want a fraction, so it's a fraction of all women. We are working with women, meaning females. So they want the fraction of the total number of females or women that were involved in a serious accident. We have fatal, we have serious, we have minor, we have none. This time they are only concentrating on serious. So we go to the serious bars, and then we choose the one for the female. We already know how many female in total involved in an accident, because here there is a few things. They want that fraction of the total number of women involved in an accident. That means not involved we leave out, and then minor and fatal we leave out. We are only concentrating on serious over the total number that were involved in any accident. But when you talk of involved in an accident, that means the none we just ignore, because they were not at all involved in an accident. So we look at the serious. How many females were seriously involved in an accident? If you look at your bars, it will lead you to 25. So they say this is a fraction of the total number of women that were involved in an accident. That means it's 25 out of the total number of fatal, serious, and minor. So which is what we calculated at the beginning. So it's 65. So you now have to simplify this one. So you see which number, the biggest number that can divide both, and then you get the simplified answer. And the fourth one, express the total number of males who were involved in an accident remember, males who were total number of males who were involved in an accident as a fraction of the men who were not involved in an accident. We are talking of two things: those that were involved and those that were not involved. But it's males, we are ignoring females. So we look at how many males were involved in an accident. Then we make it over those ones that were not involved in an accident. So we have fatal. Fatal, we have how many? Fatal for male leads you were 5. Then you add the serious. Serious for male will read you were 15. Then you add. Then we want to the ones for minor. Minor males will lead you to 20. Minor will lead you to 20. So you add these ones because they say the total number of all males that were involved in an accident over those ones that were not involved in an accident. Those ones that were not involved in an accident are the ones that are written none. So the bar for none male that were not involved in an accident, they are 30. Then you just do your calculations to simplify it and get, because they're asking, give your answer as a mixed number. So when you get now your 40 over 30, divide it further, you are going to get a mixed number because the fractions you have bigger one over small one. When you have a bigger number over a small one, it's obvious you get a mixed number. So then you will get your mixed number and then you give your answer. At times, if you are not given a graph like that one, to where you are asked a question after the graph, they might ask you to draw a graph. They give you data and then you are supposed to come up with a graph, because then you are going to also be able to teach this one to the learners. So there we have unorganized data or ungrouped data. So you need to find a way, you group it, and then you categorize it before you even think of a graph. So like this, we have learners, the learners test results. So if you have the learners, and then you have the test result. So there are those ones on the test, they only scored a 2. If you look there is a lot of 2s. So they are saying on that test, there are a few learners that scored a 2. Then you write your 2, and then you now want to know how many learners scored a 2. So you count 2s are how many? 1, 2, 3, 4. So 4 learners scored 2. And then there are also a number of learners that scored a 3. So you write, oh, there's also a 3, a score of 3, or on the result there's also 3, those ones that scored 3. How many are they? There are only 2. And then there are those ones that scored 9. How many are they? 1, 2, 3, 4, 5, 6, 7, 8. There are 8. 8 of them scored 9. And then there are those ones that scored 14. There are how many? 1, 2, 3, 4, 5, 6, 7. There are 7. Very good. And then there is even 1. There are some that scored 1. How many are they? It's just one learner that scored 1. And then there are those ones that scored 16. You would want this in your class. There are how many? 1, 2, 3, 4, 5, 6. It's 6 of them. And then there are those ones that scored even 18. That's very good. And there are how many? There are 3. And then you have those ones that scored 20. And there are 1, 2, 3, 4, 5. There are 5. You see, now our data is organized. You have your learners and then you have their scores. So on this is now very easy for you to draw a graph, because now you know I'm just going to draw my y-axis and my x-axis, the x-axis on the horizontal axis, and then the y-axis was on the vertical. So you now need to determine which one is a dependent variable and which one is the independent variable. So which one depends on the other ones? The marks depends on the learners. So then you have your independent variable is always on the x-axis. So you have the independent variable here. And then the dependent variable here, which is, but make sure you label it also. You don't just say dependent, independent. I'm just showing you that this side is, the y-axis is for the dependent variable on that data, and then the dependent variable, you label it on the x-axis. So you put here learners, number of learners. And then here you put your marks. So we arranged, we drew our lines. So now we have to think of how do we go in now to represent what we have here on the graph. So you are going to look at because usually a graph paper have small lines, squares, a lot of rows and columns. And then now when you are going to say 1, 2, 3, 4, 5, you don't just do it. You have to you decide, okay, in between here, I determine the spacing. So if you decide after every 5, I put a 1, then it means that all the way the space should be evenly distributed. Those squares should be evenly distributed. You can't have here is 10 and then there is 20. It should be evenly distributed. It should be the same, if I may say. It should be the same between a 1 and 2, a 3 and 4, and all the way. And then you can now start considering your bars. It comes from the dependent variable going, it's a box going to the y-axis, to the length now determined by the dependent variable. For example, we have a learner that scored 1. Then we already know that if a learner that scored 1, then you already have this is max. There's one learner that scored 1. Then you decide. Here you also decide the width. If you say it's always 0 here. If you say now I'm going to say 1, 2, 3, 4, 5, all the way up to the biggest, which is 20, then so be it. If you decide, then I'll do a scale of 2, 4, 6, 8, 10, all the way. So be it, as long as it's the same in between, as long as it's the same interval. So if you say I'm going to say 5, 10, so be it. It's still fine. It's up to you. So let's say maybe we can say 5. But given that now even these spaces are the same, 10, 15, 20, 25. So if they say one learner scored 1, there's a learner that scored 1, you should already know that each of these one is 1, 2, 3, 4, 5, and then the 1 is here. Then your box will just come here. It will just be this one. It won't go beyond as I was drawing it. And if they, like here they said, okay, there's also some that scored 2. Like 2 learners scored actually 3 marks. Then this is 2 learners. The 2 learners scored 3. Where is 3? 3 is also not so far. It's also somewhere here, because this is 5. So your square will just be in between here, and then that's it. It won't go beyond 3. And then we have 3 learners that scored 18. So you have 18 is somewhere here. So your 3 learners will come until you finish all of them. Until you finish it, you finish all of them drawing. But very important, you should have a title. It should have a title. So if you leave out one of these, then you also lose a mark. Especially, don't forget the title. Make sure your paragraph has the title, because we tend to leave out these small things, and then that one mark matters the most. The operation with whole numbers, principles and operations, concepts. So we have certain concepts that we've learned in mathematics. For example, the first one says write the following numbers in ascending order. You know there is ascending order and then there is a descending order. Which one is which? Familiarize yourself, go to your module, go on internet and find out which one is which. There is one that it decreases as you go along. There is one that increases as you go along. This one is saying ascending order. Find it out and then arrange those numbers in ascending order. That means from big to small or from small to big. So find out and then you can just do so. Write the following numbers in words. So if you are given a number, you should be able to spell it out in words. So those are basic things that I'm sure you can be able to do. Like there they gave you 300. Can you write 300 in words? Work out the answers. Use the BODMAS order for operation. So most of the time when we tend to ignore this word. But it's actually very important because it's a very nice guide. If you follow it as it is, it will lead you to the answer exactly as it's supposed to be. If you get an operation for you to use this BODMAS, just use it as such, as it is. Do not use it the other way around or from the end to the beginning, because it says it's a bond of division, multiplication, addition, and subtraction. You start with brackets of division, multiplication, addition, and subtraction. Start from the ones that they started with. If it's not there, check if the next one is there. If it's not there, check if this one is there. So, because they follow each other. Like there they gave you 137, you add 251, you minus 189. Follow the instruction. You come here. These are the ones we look at. So you want to know, according to this, what did they say? Which one starts? Isn't the plus, the minus? So we don't have a division that was supposed to start. We don't have a multiplication that was supposed to follow, but we have addition. So that means whatever it is there, you have to start adding first. That is step one. You add it. That is step one. And then you get, if you add this total, you get 388. And then you go to the next step. You take this one, you bring it here. Now I can go to the next one, minus 189. And then you get your answer. Then you even get ticks as you go along answering, and then the final one when you gave the right answer. So this one is a scenario. It says a firm employs 1,200 workers, of whom 240 are women. That means the rest are men. Calculate the percentage of workers who are women in the firm. So they want to know if there are 240, what is the total percentage of that? So you have 1,200 workers. And then we have 240 women. Now they want us to express this as a percentage. This as a percentage of the total number of workers. So you already know how to express as a percentage. So you take the total number of women, you divide it with the total number of workers, 1,200, Because you are looking, you want what? You want percentage, you multiply it with 100. Then you get your answer. How many percentage will you get after that? And then they said, calculate the fraction of workers who are men in the firm. They want a fraction. Remember, a fraction is 1 over what over of men in the firm. Give your answer into the simplest form. So now we have 1,200 workers. We know our women's are 240. So how do you get the number of men? So you take the 1,200 workers, you minus the number that you know, because you only have women and men. You minus the number of women, because we know that number is 240. Then we get 960. So you express it as a percentage of the total workers. Then you get, it's just 960 over the total number, which is 1,200. And then you simplify it. You make it simple. You simplify this, because they said give it in the simplest form. That means you find the biggest number that divide this and this to get the simplest, the smallest number possible. And the next one says, the population of a village in a certain Western African country was 197,682 people. After the Ebola outbreak, 6,970 people died. So now they want you to write the number 197,682 in expansion form. So when you look at the expansion form, you look at what is when you expand it, you look at the place value. For example, 197,682. So if you are going to expand it out, it means that you just write the first one, you multiply it, but the rest will be zeros. So you have 1, and then the place value of 1 is 100,000. So you multiply it with 100,000. And then you plus, because they are saying you should write it in expansion, you are expanding it out. The 9, you write 9, and then the place value for 9. If you want to determine where 9 is here, you look 100 and it's 97,682. So it's a place of 10,000. So you times it with 10,000. So it goes on like that. You look at where it is, and then the rest of those numbers will become zeros as you multiply with the place value. And then you add 7, 197,000. So 7,000. So you multiply 7 times 1,000. So you carry on like that until you finish multiplying and adding so you are expanding it out. So I'm sure you can now carry on, because you look at 680, so it's 100 times 100, and 80 is 8 times 10, 682, and then you add the 2. So this one is a plus, mind you, this one is a plus, it's not a times. So you have expanded it out. And then they want you to round off the number. So you round off the 197,682 to the nearest. You round off. So when we round off, in mathematics, when we round off from 0 to 4, and then from 5 to, okay, you can't see, rounding off 0 to 4, and then 5 to 9. So here, if the number that is next to the one to be rounded off, the one that follows that number to be rounded off, if it's within this range, you leave it same. If it's within this range, then you change it. So in this case, you have 197,682. So you need to round it off. We look at what to the nearest 100,000. That means to the nearest 100,000, you round off. The main one that they are talking about is this one. What is the number? The next number is 9. So when you round off, it changes. So if it's to the nearest 100,000, so you change by increasing. That number increase. But now that is a 9, the 1 becomes 200,000. Because there's a 9 here. It's in a range of 5 to 9. And when you change, you increase the number, that number that is supposed to be changed. But if there was a 4 here, we were going to leave it at 100,000. But now that is a 9, then we increase this one, it's a 200,000. You have the numbers, and then you have not circle, actually they are dotted lines. So now you are supposed to use those operations to get the correct answer. So if you multiply 7 times 4, what are you going to do there? And then either you plus 3, you minus 3, you divide 3, you times 3 to give you 25. So for example, what is 7 times 4? And then you need to do something here that agrees with this 3, and then at the end you only get 25. You see if you are going to add, if you are going to minus, if you are going to divide, if you are going to multiply this with 3, and then it will give you 25. Terminations and operations with money. Working with money. You go to a shop, and then you are supposed to know how much is the item cost. If I have this many items that I need, how much in total do I need to carry? Or if I have this much, how much is each item cost for me to get the number that I want? So like here, they are saying there is a 6, 1 out of 2 kilogram of potatoes that is costing 15 per kg, per kilogram. So here they might ask you, how much do you need for the whole 6? Because this, how much is the total number? if you want 6.5 that is going to cost you per kg is this one. So you multiply this with this and then you get how much money. And then a 4 kg of beef, and then it costed 90. Now the question is, how much is each cost? How much does each cost? Then you already know that if I have 90 and I manage to buy 4 kgs, if I divide the two, it will give me how much each have costed me. And then here, the next one, there is this person has 66.5. Bought, like you bought coffee, per jar was $9.50, and then you managed to buy for 650. So how many jars did you buy if you bought of this amount at this price? So again, you just divide here, and then you get 9.50, and then you get the number, the total number of jars of coffee. Okay, at the local food store, a loaf of bread cost $5.95. A 2-liter bottle of Fanta cool drink costed 19.89 cents, and a 500-gram portion of chips costed $14.75. James bought 2 loaves of bread, 1 bottle of 2-liter Fanta cool drink, and 4-gram portion of chips. So now they want you to estimate the total number that James has to pay for all those items. They already told you how much each costed. Now this person went and bought more than one. So now what you have to do is, for each you just have to multiply it with, for example, you have bread, 1 loaf cost $5.95, but then this person ended up buying 2 of them. That person ended up buying 2, so you have to get how much. So, but then here you are not going to use this one because they said you need to estimate. When we estimate, we use the same concept. So if it's $5.95, so if you have to round off, it will give you $6 on a dot. So it's this $6 that you multiply with 2 to give you $12. It's the same. It's the same. For the Fanta, he bought 2 liters. He bought 2 liters of cool drink. Just one is fine. You just have to round off. You just have to round off 19.89, and then you get if you round it off, you need to carry $20. See? So if for example, the next one is the portion of chips costed how much? $14.75. So you need to carry, if you have to estimate, you will have to go with $15 for it to be enough. So you say this $15. He ended up buying 4 of them times 4, and then you get $15 times 4, then you get 60. That is all you add together to give you the how much is this person, because this is money. This is money, how much that person is going to pay at the end of the day. So then the next one, you need to calculate the exact amount. When they say the exact amount without saying estimate, then you calculate it as it is. Because of time, we are rushing now. Let me just do one of these two. So if they ask you to complete this, the time, when it comes to time, and they ask you to complete the table. Most of the time when students write, for example, you have 8:35 a.m. but you are given 24 hours to fill, and then you are given words. You should also write it in word. Most of the time, struggling with word is not really that, but a portion of it, they always find a way to not to include this in their explanation in words. But for example, this one, you have to say 35 minutes past 8 in the morning. But if it was here, because here 24, you already know 24, this will be 20, 35. So then this will be, is 35 minutes past 20. So you do the same in both ways. The other side you put in words, and then the other side you will have to write it based on what time or hour system it is. If it's 12, you know it's only from 1 to 12. The only thing that changes is AM or PM. Or not PM. Here you can't put PM because then it goes to 24. You can be able to tell. But here you always have either 8:35 a.m. or so this, or 8:35 p.m. You always have either AM or PM. So now when you write it in word this side, then you are supposed to say 35 minutes past 8 in the evening. Don't leave out this one when you are explaining. You also interpret it. Yes, is. Then sometimes you get the diagram and then they ask you, like here they're asking you for the similarities, or they ask you for the line of symmetries because we are dealing with shapes, dimensions, three-dimensional shapes. So they ask you either the symmetry or they ask you to give the characteristics. Sometimes they give you number 3 to choose. So they give you the 27 angle. Then you know that if you have all the names, you need to know the angles. How many, like an obtuse angle has how many, obtuse has how many angles? Straight, the angles that is straight has how many? So it's 180 degrees. So you need to know the degrees for each angle for you to be able to identify. This one is a right angle triangle, not triangle, but the right angle. This one is a revolution. This one is a revolution. This one is a right angle. This one is, so you need to know all of them. You need to know, as soon as you know the degrees, and then you know the angles. Because they will just give you the list, and then you're supposed to, the list, and then they give you the degrees, and then you're supposed to state which one is which, you choose amongst those ones. So you get, sometimes they ask the theory in mathematics also, like the importance of mathematics in the daily life, or as a teaching aid, what mathematics teaching aids, what teaching aids do you use, and then you're supposed to give the teaching aids that are used in mathematics, and then the importance of punctuality, how learners can manage their times. So you meet such type of questions in mathematics also, not just calculations. So thank you very much. Those are my contact details. Like I said, I was assisting with your mathematics tools, but do ask questions through my email or my cell phone number. I'll be very happy to answer them. Thank you, and good luck for your exams.